In 1843, a brilliant engineer named Norbert Rillieux walked onto a Louisiana sugar plantation and witnessed something that would haunt him for the rest of his life. Enslaved workers, their arms scarred with burns, stirring boiling syrup in open iron kettles. The heat was unbearable, the danger was constant, and every drop of sugar you've ever tasted came from this hell. But Rillieux had an idea. What if 3 simple pans could think for themselves? What if you could make steam do the work without any human hand ever touching that fire again? The problem was, he wasn't white, and in 1840s Louisiana, that meant his genius was about to collide with a system built to destroy him. Norbert Rillieux was not supposed to exist. Born in 1806 in New Orleans, he was the son of a wealthy white engineer, Vincent Rillieux, and Constance Vivant, a free woman of color. In Louisiana's bizarre racial hierarchy, that made Norbert free, but not equal. His father saw his brilliance early. At 17, Norbert wasn't sent to an American university. There was no point. He was sent to Paris, to the École Centrale, one of the finest engineering schools in the world. And here's what's incredible. At 24 years old, he became an instructor, teaching thermodynamics, teaching steam power, teaching the physics of heat transfer to French engineers. But he couldn't stop thinking about home, about those kettles, about that suffering. So in 1830, he returned to Louisiana, and that's when his real education began. By 1833, Rillieux had a plan. He'd work for Edmond Forstall, a prominent refinery owner who needed an engineer. The traditional method was called the Jamaica train, a line of open kettles, each one hotter than the last. Enslaved workers would ladle syrup from kettle to kettle as it thickened. It was brutal, it was dangerous, and it was incredibly inefficient. Most of the heat escaped into the air, the sugar often burned, turning dark and low quality, and the human cost? Impossible to calculate. Rillieux's first idea was simple. What if we could enclose the process, seal the kettles, trap the heat, reduce the temperature needed to boil the juice? He called it the single-effect vacuum pan. You create a partial vacuum inside a sealed chamber. Lower pressure means water boils at a lower temperature. Less heat means better sugar and safer conditions. He built one, and it worked. But then, disaster. Edmond Forstall and Vincent Rillieux, Norbert's own father, got into a bitter business dispute, and Norbert, caught in the middle, chose his father's side. He quit. Years of work, his first successful machine, gone. For the next 6 years, Rillieux wandered. He tried to get other refineries interested, but he faced a problem more intractable than thermodynamics: racism. Plantation owners didn't want to hear ideas from a free man of color. Patent officials questioned whether he even had the right to file applications. And when he did manage to install equipment, he wasn't allowed to stay in the main house. He slept in outbuildings, ate separate meals, was treated as less than human by people using the machines his mind had created. But he kept working because he'd had another idea. What if one pan wasn't enough? Here was Rillieux's insight, and it's one of the most elegant ideas in the history of engineering. When you boil sugar juice in the first pan, you create steam, hot steam. That steam is wasted heat escaping into the air. But what if you could use that steam to heat the second pan, and then use the steam from the second pan to heat a third? One fire, 3 effects. It's called the multiple effect evaporator, and the moment Rillieux realized it was possible, everything changed. Let me show you why this is brilliant. First, the vacuum principle. In each sealed pan, you lower the pressure. At normal pressure, water boils at 212 degrees Fahrenheit. But at reduced pressure, it might boil at 150 degrees or even 120. Lower temperature means the sugar doesn't caramelize or burn. You get pure white crystals, premium quality. Second, the cascade. The steam from pan 1 is still hot, maybe 200 degrees. That's more than enough to boil the juice in pan 2, which is at even lower pressure. So, the steam from pan 1 becomes the heat source for pan 2. Then the steam from pan 2 heats pan 3, each one reusing the energy from the previous one. You're not burning 3 times as much fuel, you're using the same heat 3 times over. It's thermodynamic alchemy, and it all happens automatically. No human hand touching boiling syrup, no workers ladling liquid between open fires. The machine does the thinking. In 1843, after 12 years of struggle, Rillieux finally convinced a plantation owner named Theodore Packwood to let him build it. It worked. 3 pans, 1 fire, perfect sugar, and no one burning. So why did this matter so much? Because in the 1840s, sugar was everything. It was in your tea, your coffee, your desserts. The entire economy of the American South depended on it. Louisiana alone produced over 200,000 tons per year. But the human cost was staggering. Sugar plantations were considered the most brutal form of slavery. The heat, the danger, the relentless pace, it broke people. Injuries were constant. Burns were so common they were barely remarked upon. And the inefficiency? From field to crystal, you lost 80% of your cane juice. Burned sugar, wasted heat, spoiled batches. Rillieux's machine changed everything overnight. Yields increased by 30%, quality improved dramatically, and the workers? They no longer had to stand over boiling kettles for 12-hour shifts. By 1846, his system was being installed across Louisiana. By the 1850s, it spread to Cuba, Mexico, Europe. But here's what should break your heart. Rillieux never got rich. Patent pirates copied his design. Plantation owners refused to pay fair licensing fees to a black inventor. And then came the ultimate betrayal. In 1854, Rillieux proposed a system to drain New Orleans swamps to stop the yellow fever epidemics that killed thousands. His engineering was sound. It would have worked. But Edmund Forstall, remember him, now sat on the city board, and he blocked it out of personal spite. In 1861, Rillieux left America. He returned to Paris, and he never came back. He died there in 1894, reportedly heartbroken. Recognized in Europe, forgotten in America. Here's what they didn't tell you in chemistry class. Every time you add sugar to your coffee, you're using Rillieux's invention. That white crystal in your hand, it exists because of the triple effect evaporator. The sugar industry still uses his system, refined, modernized, but fundamentally the same principle. Cascade evaporation under vacuum. But the echo goes far beyond sugar. Rillieux's invention became the foundation of chemical engineering itself. The multiple effect evaporator principle is now used in milk processing, condensed milk, powdered milk, pharmaceutical manufacturing, concentrating medicines, desalination plants, producing fresh water from seawater, paper mills, concentrating pulp, soap production, glue manufacturing. Anytime you need to concentrate a liquid without destroying it with heat, you use Rillieux's insight. Cascade the energy, lower the pressure, reuse the steam. And here's the cruel irony. In 1934, 40 years after Rillieux died unknown in Paris, the American Chemical Society placed a plaque at his plantation in Louisiana. They called him the father of chemical engineering. The black engineer that Louisiana rejected, that America forgot, that died heartbroken in exile, is now recognized as one of the founders of an entire scientific discipline. His vacuum pans saved countless lives, not just by ending the brutal labor of the Jamaica train, but by making medicine manufacturing possible, by making water purification scalable, by turning chemistry from an art into a science. Think about that. A man who wasn't allowed to sleep in the same house as the people using his machines created the foundation for modern industrial chemistry. A man blocked from saving his own city from yellow fever, whose principles now purify water for millions. The next time you open a can of condensed milk or take a pharmaceutical pill or turn on your tap and get clean water, you're touching Rillieux's genius. 3 simple pans thinking for themselves.